All right, so we want to look at cumulative frequency graphs. Cumulative frequency is something we mentioned before, just in sense of a table, but I want you to be aware of how the graphs are actually constructed. And I will tell you, almost every IB exam I've seen has at least one cumulative frequency graph on it that you have to read and interpret, okay? So let's look at this. We had mentioned percentiles before, okay? The quartiles are on the 25th, the 50th, the 75th percentile, okay? We could even say that the max would be what percentile? The 100th percentile, okay? Okay, so those percentiles, remember, it's the value that is greater than that percent of the data. Okay, so the 25th percentile is greater than 25% of the data, and so on. Okay, or at least. It says that it's the percentage of the data lies at or below. So you have that less than or equal to kind of aspect there. All right. So when we're dealing with a cumulative frequency graph, we're going to actually incorporate both of these ideas here. We need a cumulative frequency table. We have the y-axis that is going to be your cumulative frequency. And then for the data, if it's continuous type data that's given in ranges, we always use the higher end of the range as our x value when we're plotting it. Okay? So, for example, here we have some data from the 2008 Olympics, the women's marathon. Okay? All of them took over 2 hours to finish. Okay? Or were within 2 to 3 hours. So, I'm actually going to label our x-axis in terms of the finishing time in minutes over 2 hours. Okay? So it's minutes over 2 hours. So your x-axis is always your data points. Your y-axis is always your cumulative frequency. Okay? So this column right here is going to actually give us all of our y values. What do you notice about all of those y values? Okay, they're greater than just the frequency. What do you notice about them?
Y is a percentile or y?
No, y is cumulative frequency. We'll talk about percentile in a sec. But y is cumulative frequency. What do you notice about these numbers?
Increasing.
They're increasing, which makes sense because it is cumulative, all right? Your cumulative graph will never go down at all, all right? You can't have negative people in a category, so you're not going to lose anything when you're doing cumulative frequency. Okay? Now, the other thing is, notice our x values are going to be these values right here. Notice we have ranges, and I'm going to use the higher end of each range, because when I put that point there, I'm saying that this y value accounts for the number of people, or I'm sorry, this y value is the number of people that is this or below. Okay? So, for example, my first point here is going to occur, I'll put a little squiggle there, and we're going to start at 28 minutes. There's a total of 8 people who finished at 2 hours 28 minutes or below. Okay? So let's say that this is 10. Okay? So we'd have a point right here at 28.8. Okay? You don't always have to label all these points. I'm going to, because we don't have a real good grid here to work with. Okay? If I ever ask you to do this, I will give you a very detailed grid that you can work with. to do it, okay? So there's 28. The next x value that we have will be 30. So at 30, what's our y value? 11, okay? So notice here, cumulative frequency, there were only a total of 8 up to 28, but now we add the 3 to it, 8 plus 3, now we have a total of 11 people that are at this time or below, okay? So there's our point 30, 11. Yes?
Why do you have on the y-axis you have 10 if it's 8?
Well, I'm just using that as kind of my hash mark. So I'm going to go up by tens here.
Oh,
10,
okay.
20, 30, 40, 50, 60, 70. Okay? So that's just my scale on the y-axis. Okay. Now, what's my next point going to be?
32, 20.
There we go. 32, 20. So here's 20. So I come straight across the best I can here. So there's my point 32, 20. Okay? So we just plot the rest of these. 34, 31. Okay? 34, 31. So here's 30, so just above that. Okay? Then 36, 43. There's 40. Then 3850. And then 4055. Okay, so if that's 60, it's going to be right in the middle there. So 40, 55. Okay. Then we have, now notice here, there's a gap. Be careful with this because sometimes when there are fewer at the end, if it starts tapering off, they'll make a bigger gap here. It's not like those histograms where it has to be even all the time. Okay? So here we have 48. So here's 42, 44, 46, 48, 63. So 48, 63 would be about there. And then finally another gap up to 56. So 50, 52, 54, 56. And it's 56, 69. Now, once you get all of those points, don't do it like a broken line graph. Try to make it a curve the best you can. Okay? Because the idea is that, you know, people are finishing kind of throughout that time. Also, from the first point, you'll go straight to the origin. Okay? Because the assumption is nobody has finished at 0 time. Okay? So that would be our cumulative frequency graph. So we've done part A. That was the table. That I think you guys didn't really need to do on your own there, but that just made sense. Okay. So here's our y's. I will circle these. These are our X's. Okay? So let's talk about interpreting this. Interpreting this. It says that we can use our graph to estimate the median. Now, first of all, how many competitors do we have here?
69.
69 of them, okay? The total number is going to be whatever that last cumulative frequency is. By that time, everybody has finished, okay? So, if I'm looking for the median, which value or which score am I looking for if we have 69 total runners?
Just that about 2
And then round up. Yeah. So you'd have 34 and a half. So the 35th, right? So if I'm trying to estimate the median, I'm going to go to the 35th score. Now notice here what I can do. All right, I come straight across here, and this is where having a straight edge is helpful. Okay, I know I'm not using one here, but using a straight edge is helpful. But now you come straight down. All right, and we can see, okay, so the median time, what would you say is approximately? 2 hours and
37 minutes.
not 37.
35.
Yeah, it's between the 34 and the 36, so approximately 35.
How you figure that out?
Basically, since there are 69 total runners, the median is going to be the middle score, right?
Okay.
So the middle of the 69 scores would be the 35th score. So I came over here, since these are my frequencies, and I came over here, where did the 35, or I should say, when did the 35th person finish? I see where it hits the graph, and basically I'm looking for that point. That point is approximately 35. 35. So the 35th runner finished at approximately 2 hours and 35 minutes. Okay? How many competitors finished in less than 2 hours and 35 minutes then? Half. Okay? So since the 35th one is right on the median, we wouldn't count that one, so approximately 34, right? Approximately 34 runners finished in less than that time. Is that making sense? Okay. Now, the percentage of competitors. Let's change colors for this. The percentage of competitors that took more than 2 hours 39 minutes to finish. So here's where we've got to look. Here's 2 hours 39 minutes. I'm going to go straight up from there and see where that intersects my frequency graph. Okay? It looks about right there. So now I'm coming over across. And here's where we have to use a little bit of estimation, okay? Now, based on the other points that I have, I know it's going to be between 50 and 55, right? And it looks a little bit closer to 50 than to 55. So we could say maybe 52 are at that value or below, okay? So approximately 52 finished in less than, notice less than 2 hours 39 minutes. So how many took more than that much time?
17.
Yeah, so 17 out of the 69. Okay? 17 out of the 69 took more than that amount of time. And you guys can figure out what that is as a percentage. Okay? Now, the top 20%, real quickly here, the top 20%, here's where you have to kind of think about the numbers you're dealing with, all right? 20% of 69 is 13.8. Now, the 14th person, therefore, would be out of the top 20%. So in other words, this means your top 13. Which doesn't mean the top of the graph, because those are the slow people, right? So it's the very first 13 people. So you come over here, where are these 13? Okay. They'd be at approximately 2 hours 31 minutes. Okay, because here's 30:11, so approximately 2 hours and 31 minutes. All right, does that make sense? All right, so a lot of inferences we can make on this, and you can do any of those percentiles the same way we did this 20th one. Okay? All right, we'll let you guys go. Have a great day.